Our planet Earth, along with the Sun, a star, and all the planets surrounding it with their respective moons, are part of a huge galaxy called the Milky Way. A typical universe is, in essence, a large group of stars, gas, and dust with gravity binding all these together. They come in different sizes and shapes. Our Milky Way is a large barred spiral galaxy. The stars you see in the sky at night are all present in our very own Milky Way galaxy. But what will you find if you look right in the center of the Milky Way galaxy? If you want to find out, then keep on watching. And while you're at it, hit the like, subscribe, and bell icon buttons to get more of our related content. Now, without any further delay, let's get right into it. In 2009, physicists Lisa Goodenough and Dan Hooper discovered that the heart of the galaxy was shining oddly bright. Sure, there's a whole bunch of stars present there, along with a black hole that is 4 million times the mass of our Sun. Still, even if we subtract the light emitted from all these objects, we're left with this mysteriously glowing area in the center of the galaxy. This area of extreme brightness, now referred to as Galactic Center GeV-XS (GCE), has puzzled scientists since its discovery. Data from NASA's Fermi Gamma Ray Space Telescope suggests the presence of excess gamma radiation, believed to be the most energetic light in the universe. But what would cause this sudden surge of gamma radiation in the core of the Milky Way? Scientists have debated over the source of this unexplained light. In the years since its discovery, scientists have laid out a range of sources that could be causing this gamma light emission, from long-sought signals of dark matter, which is the invisible form of mass believed to suffuse the universe, to more conventional sources, like a group of extremely fast-spinning stars called pulsars that are too dim to observe with current telescopes. At present, a physicist from the National Institute for Nuclear Physics in Italy, Mattia Di Mauro, has shared his 2 cents on the subject matter. According to his analysis, the existence of GCE points back to the presence of dark matter, an explanation also put forward by Lisa Goodenough and Dan Hooper. But what really is dark matter? Honestly, the makeup of dark matter is still unknown to us. All we know is that it's a mysterious mass all around us, and that stars and galaxies feel its gravitational effects. This gravitational pull cannot be explained by the stuff that we can normally detect, those being stars, dust, galaxies, and gas. Consequently, galaxies are believed to rotate much faster than they should if they were only experiencing the gravitational effects of the ordinary matter in them. This peculiar effect is called gravitational lensing, defined as bending of space-time around massive objects. It's far stronger than it should be, hinting that the presence of dark matter is responsible for such, since whatever is causing this additional gravitational effect is beyond our ability to detect directly. So, we know about the dark matter only through gravitational effect it has on other objects. According to numerous resources, there's a lot of it out there, making up about 80% of all matter in the universe. It's funny, however, how we can't even visualize a tiny scrap of it. Lisa Goodenough and Dan Hooper propose that at the center of the galaxy, where abundant dark matter is present, certain dark matter particles called weakly interactive massive particles, WIMPs, annihilate each other with their collision. This happens because these particles are thought to be their antimatter counterpart. Just as matter and antimatter destroy one another on contacting each other, 2 WIMPs would annihilate if they collided. As the WIMPs smash together, they release a massive shower of gamma-rayed photons. This explanation was backed up by a lot of data and observed through NASA's Fermi Gamma Ray Space Telescope. However, a bunch of other physicists was not convinced and deemed this explanation shaky. But the light may have a more mundane origin. In 2018, another team of scientists proposed that the pulsars could be causing the emission of gamma-ray light. Pulsars that we haven't yet visualized are the leftovers of a once large stars that have run out of fuel for nuclear fusion, and because of which have collapsed. These remnant stars spin at dizzying speeds, taking a millisecond for each full rotation, and shine their light in condensed beams. The emitted light rays are the gamma ray photons and could be the culprit that contributes to the bright GCE if enough pulsars are hiding here. Two recent studies that came out before the analysis by Fermi support this scenario by suggesting that the extra gamma ray light, or the distribution of the GCE, look a bit clumpy rather than smooth. These clumps and speckled appearance would be expected if the light originated from individual objects or point sources, such as stars, pulsars. A smoother appearance would be expected from the annihilation of dark matter particles spread evenly through space. Afterward, another team of scientists came along and put forward that the speckled gamma radiation could be produced by dark matter, putting it back on the table. Yet more researchers then generated a series of exhaustive models of the galactic center with dark matter annihilation using a range of masses across the most commonly searched regimes. Through their models, it was found that the WIMPs were unlikely to be the cause of GCE. Coming back to DeMauro, he conducted a study that compares data from the Fermi telescope over the last 11 years against measurements of other astronomical anomalies recorded by the Pamela Cosmic Ray Detector aboard the RESER's DK-1 satellite and the Alpha Spectrometer experiment aboard the ISS. His study in particular uses the broad set of data from Fermi collected over the past year and minimizes the uncertainties introduced by background radiation. According to DeMauro, this has provided information about spatial distribution of GCE, which can help in ruling out various theories. He goes on to explain, if the excess were, for example, caused by the interaction between cosmic rays and atoms, we would expect to observe its greater spatial distribution at lower energies and its lower diffusion at higher energies due to the propagation of cosmic particles. My study, on the other hand, underlines how the spatial distribution of the excess does not change as a function of energy. According to him, this has never been observed before and could be explained by dark matter, since we believe that particles of dark matter should have a similar range of energies. The analysis clearly shows that the excess of gamma rays is concentrated in the galactic center, exactly what we would expect to find in the heart of the Milky Way if dark matter is in fact a new kind of particle, he said. The reality of the particle is still a huge mystery to us and has scientists scratching their heads. DeMauro and his colleague Martin Wolfgang Winkler of Stockholm University in Sweden issued a second preprint paper in which attempts were made to bring it out of the shadows by looking for a gamma ray excess in nearby dwarf spheroidal galaxies. They weren't able to find one, but null detection has enabled constraints on the dark matter particle's mass. According to the two, these constraints are compatible with the GCE. What does this mean then? Is dark matter the cause of GCE? The answer is no. However, this also means that we can't rule out the dark matter isn't causing it either. The whole scenario is as puzzling as it's ever been. To solve this entire mystery behind the cause of GCE, we're going to need a lot more scientific observations and experiments even to begin untangling it. We can already sense a significant disturbance in the force, like that of many physicists around the world rubbing their hands together like toddlers in anticipatory glee. Excited yet? Keep up with our content to get updates regarding this curious phenomenon by subscribing to this channel and pressing the bell icon. If you want more such content, be sure to press the like button. Adios!